All right, hey guys, this is section 11.6, solving systems with Gaussian elimination. First, we're going to talk about some definitions, some rough definitions. So we already talked about what matrices are, and here is what you call a matrice in row echelon form. And basically what this means is that there are ones on the main diagonal, here, here, and here. And you can tell this is the main diagonal because it's the spot where the column number and the row number match. So this is column 1, row 1, right? This is row 2, column 2, and this one here is in row 3, column 3. And so generally what you're trying to do is get these ones on this main diagonal, and it works for any square matrice, whether it's a 4x4 or a 2x2. You essentially want all the numbers that this line from the upper left corner to the lower right corner goes through to be ones. You want zeros on the lower left part of the diagonal, so you can kind of think of this as like a little triangle. You want zeros there, and then these numbers could be whatever numbers they want to be, and this is essentially row echelon form. Okay, and then kind of taking this idea a bit further, this is row reduced echelon form, where once again the main diagonal has ones on it, and remember that the main diagonal is all the entries where the row and column number match, and having zeros everywhere else. And so this guy is really what we're going to be working towards for the most part, not the row the row echelon form here. So we're going to go for the one with all zeros everywhere. And how do we get these zeros? Well, we get them using row operations. And so for row operations, you basically only have three tools to use. You have interchange rows, which means you can swap rows, multiply a row by a constant, which basically just is a number. Constant is another way of saying a number, so like 2 or 3 or 4. And then your third option is to multiply a row by a constant and add it to another row. And these are the only three tools you have so that you can obtain row reduced echelon form. Okay. So here's an example of what the first operation, interchanging rows, looks like. You see in our first row here, we have the number 6, 7, and in the second row we have 8, 9. So interchanging rows, the first row becomes 8, 9, the second row becomes 6, 7. And in this case, since these are only 2x2s, they're touching, but they don't necessarily have to be. You can swap any row with any other row. Okay? All right, the second tool that you have is multiplying a row by a constant. This is the second thing you can do. So for instance, in this example, we're multiplying the first row, R1, row 1, by 2. So 2 times 2, which is 4, and then 2 times 3, which is 6. And you can see that the second row didn't change at all. And typically, aside from this swapping rows, you only ever change one row at a time. All right, let's take a look at what multiplying a row by a constant and adding it to another row looks like. So here, you can see what we're doing is we're taking row 1, which is 1, 2. Excuse me, let me space that out a little bit. And we're multiplying it by 2, which gives us 2, 4. And then we're adding these numbers here to row 2, which is 3, 4. And 2 plus 3 is the 5 that you have here. And 4 plus 4 is the 8 that we have here. And so the sum of these numbers is what replaces the row you added to. So we added to row 2, and so row 2 is the row that gets replaced. You can tell that row 1 hasn't changed at all, and that's how it's always going to be. The row that you multiply to doesn't change, but the row that you add to is the one that will replace. Okay, and so what are these row operations help us do? Well, the first two row operations help us get those ones on the main diagonal. And the third row operation helps us get the zeros where we want them. And so we're about to go through an example where we kind of discuss how to go about it, what's the best method, and solving the system. So let's do that. So we've already solved systems before using the elimination method and the substitution method. So let's solve a system using Gaussian elimination. So here's our simple system. 2x plus 3y equals 6, and x minus y is equal to 1/2. Okay. And this is solving a system of equations using Gaussian elimination. Cool. All right. So basically all you do is you take this system and you take the numbers in front of the variables and place them in a matrix. And what you want to do is all the x's go in the same column, all the y's will go in another column, and then all the constants, the numbers, will go in a separate column, separated by a line. And so this is where all the numbers will go. And so let's put this one in a matrix. And so we have a 2 in front of the x, and then a 3 in front of the y, and then the line for the constants, and then a 6, a 1 for the x, a -1 for the y, and a 1/2. And so we're basically only focused on this part of the matrix, and whatever happens to the right side is just what happens. This is kind of not what we're focused on too much. And so what we want this to look like when we're done is like this, right? This is a 2x2 matrix, and we want ones on the main diagonal, one on the first row, first column, second row, second column, and then we're going to have numbers here where A and B are. Okay, so this is kind of what we're looking for when we're finished. And so the first thing you want to do, the first step, is to get a 1 in the first row, first column, where the 2 is. And so how do we go about doing that? Well, remember we have only our 3 tools. We can swap rows, multiply a row by a number, and then multiply a row by a number, and add it to another row. And so these first two operations help you get ones. So you swap rows, if it'll help you get a 1 where you want it, and you can multiply a row by a number to help you get a 1 where you want it. Once you have the 1 where you want it, you use the third rule to get zeros everywhere else. Okay? So I see that I have a 1 here in this column, which I want a 1 in this column. The only thing is I want it in this row, right? And so what can I do? Well, I can take row 1 and swap it with row 2. And this will give me, and you're swapping the entire row. So I get 1, -1, 1/2, and then 2, 6. And so I've achieved my first goal of getting a 1 in the first column, first row. And the second step you're going to do now is you want zeros everywhere in that column. So everywhere in this column, you want zeros everywhere but where the 1 is. And so how do we get zeros? Well, it's by using the third method, right? And so we can do that by figuring out what number plus 2 is going to be 0. And it's always going to be the same number but opposite sign. So what we'd like this one to be is a -2, so that when we add it to 2, it becomes 0. And lucky for us, that third rule doesn't change the row you multiply to, it changes the row you added to. So what we're going to do here is we're going to take negative 2 times row 1, and if we only did this, this would change the first row. But if we add it to row 2, this will change the second row. And so negative 2 times 1 is negative 2, plus 2 is 0. And the first row stays the same here, so we don't even really need to worry about anything changing. We can just rewrite it. Negative 2 times negative 1 is positive 2, plus 3 is 5. And then negative 2 times 1/2 is negative 1, plus 6 is negative 5. Oh, excuse me, positive 5. Okay? And so now we're basically finished with this column because we have a 1 where we want it and zeros everywhere else in the column. And so now we want to move to our next diagonal spot, which would be where the 5 is, and now we want a 1 there. So the ways you get 1s are you either swap rows or you multiply by a constant. And so we kind of have this negative 1 here, which you might think, oh, if we could swap it, it's basically a 1. But the idea is that you would be moving this 1 here as well. And so once you've completed a column, you don't really want to swap this row because it's going to get rid of the 1, and you want a 1 here, right? So you're basically going to be undoing all the work that you did. So instead what you should do is take row 2 and multiply it by 1/5. And that's because 1/5 will essentially cancel the 5 we have in there. And so what we're going to get here now is, and remember, since we're multiplying just by row 2, we're not adding it to any other row, it's the row 2 that's going to change here. So 1/5 times 5, that's going to give us a 1, and the same thing to the other 5, which is also going to give us a 1, and the first row stays the same. Okay, and now what we want to do is, now that we have a 1, sorry, I wrote that incorrectly, this is a 1. Now that we have a 1 where we want it in the second column, we want zeros everywhere else in this column. And how can we do that? Well, we want to add to this row so this becomes a 0, right? And you'll notice that because this is a 0, no matter what number we multiply by, 5, 10, it'll multiply by 0, which will basically get rid of it, and then when we add it to 1, it's not going to end up changing our 1 at all. And so what number do we want to multiply by? And what you should notice is that 1 is already the additive inverse of negative 1. And by that I mean that when we add 1 and negative 1, we're going to get 0. So we don't really have to multiply by anything here. And so what you could say is 1 times row 2 and then add it to row 1. And so which row is this going to change? The row you're adding it to, right? Not row 2, but row 1. So we can write row 2 exactly as it is because it's not going to change. And so now we do 1 times row 2. So 1 times 0 is 0, plus 1, well that's 1. And that should stay the same like we said. 1 times 1 here is 1, plus negative 1, that's going to give us a 0. And then 1 times 1 here, that's going to give us 1, plus the 1/2, that's going to give us 1 and 1/2. Or we could write that as 1, 0, 3 over 2, 0, 1, 1. And so now you'll notice that we have exactly what we were looking for. We have 1s on this main diagonal, and we have 0s everywhere else. Cool. And so what does this essentially say? Well, if you remember, this was the column of our x's, this was the column of our y's, and this is the column of our numbers. So how do you read this in matricy form? This basically says, this top line basically says 1x equals 3 over 2. And this row says 1y is equal to 1. And it's because we have 0x plus 1y equals 1. We have 1x plus 0y is equal to 3/2. So this just tells us x is equal to 3/2. And this tells us y is just equal to 1. So the point at which these two lines intersect is the point 3/2, 1. And so we've solved our system using Gaussian elimination. And so you could do a 3 by 3 matrix You could do a 4 by 4. The same type of steps though. So I'm going to cut the video here, and in the next section, we're going to figure out how to find an inverse matrix using these same row operations.